scientific notation is a way of looking at really, really big numbers or very, very small numbers and communicating them more effectively. So we're taking big numbers or very small numbers and kind of putting it in the same communication. And it stops us from having to do all these big zeros. We're going to look at the significant numbers. So in this case, the significant numbers are 1 and 4, and all these other ones are kind of like saying times 10, times 10, times 10, times 10. So the way we communicate scientific notation is to put a number and then times 10 to a power. So this way we're saying times 10, times 10, times 10. In this case, it's a bit different because we've got a negative number. So what we're looking for when we communicate a big or a small number is having one digit, the decimal point, and then every other digit after that times 10 to a power. Okay, so that's going to be how we communicate both of these numbers. We don't know what that power is just yet. And in this case, we're going to turn scientific notation numbers into regular digits. So the way that we do this is we move the decimal point. So the decimal point doesn't actually move. We're kind of moving the numbers around the decimal point. So in this case, we've got our number here, which is 14 million. And at the moment, the decimal point is sitting at the end of the number. What we need to do is move it all the way along the number so that there is only one digit before the number. So this is the way we'll move it. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. Now if we look at that, we've got 1.4. I'm just going to take my fingers off that. We will have 1.4. All those other zeros don't really mean much after the decimal place there. Times 10 to the power of, how many times did we move it? Let's do it this way. It starts here. We went 1, 2, 3, 4, 5, 6, 7 times. So we do 1.4 times 10 to the 7, right? In this case, we have our decimal point in the middle here, right? We can see it here, and what we are trying to do is the exact same thing. We're trying to get it to a point where it's got one digit, the decimal place, everything else that's important, times 10 to a power. So we're going to end up with something times 10 to a power. So let's move it along. You can see this time we're actually moving it a different way. 1, 2, 3, 4, 5, 6. We've had to move it 6 places along. So we will have a 6 up here, but because we moved it backwards, we will have a negative 6. And what we'll be left with is 7.6 times 10 to the negative 6. Right? We've moved everything along, and we can practice one more time. We can see this is going to the left. This time 1, 2, 3, 4, 5, 6 is going in the opposite direction. It will have a negative power if it is a very small number, and we can see that this is a very small number. It will have a positive power if it is a big number, and we can see that that's a big number. Okay, let's do the opposite now and move these to a normal digit. So we have 3.49. Instead of having the decimal place here, we're going to move it 3 spaces. It's positive, so it's going to be a bigger number, so we're going to move it 1, 2, 3. Now the decimal point would be here, but we've got this big gap here. And remember that we've got a times 10 to the 3. So what we're looking at here is a 0. So this 3.49 times 10 to the 3 is actually 3,490. If we do the same with this one, we've got a 6 and a 2. Our decimal point starts here, and it's going to move in the opposite direction this time. It's going to be a very small number, so these digits are going to be down the back end of the number. So 1, 2, 3, and 4. If this is where our decimal point is, has to have a 0 in front of it, and we're going to fill these gaps with zeros. So this number here, 6.2 times 10 to the negative 4, is 0.00062. So we have to know how to be able to move big or small numbers into scientific notation and to move scientific notation numbers into regular digits.